আচ্ছা কেন কথা বলি
কি ওটা দিব বুঝি আর আরাম আছে না
Good morning, everyone. Welcome to our Institution of Global Professional Free Webinar. Thank you all for joining with us in this wonderful morning. My lovely audience, today I am your host for the morning. I'm Yarni Sakhtar Chaudhary from Bangladesh. Ladies and gentlemen, I'm proud to be associated with IJP as a global member. I feel honored to host this webinar. It's my delight to welcome you all to our Institution of Global Professional Free Webinar. Thank you all for joining us today in this marvelous morning. And it's my humble request to you, all of you, stay with us till the end. And don't forget to tag, share, and mention your friends. So let's together and learn together. Today, our webinar topic is image segmentation, machine or deep learning. Today, we have our speaker. Our speaker name is Mohammad Lawal Turu. He is a research scholar from Thomas Polytechnical University, Russia. Let's welcome our speaker. Hello, sir.
Hello.
Welcome, sir.
Thank you for giving me the opportunity to make my presentation.
Sir, you can start your presentation.
Can you see my slide?
Yes, sir, I can see.
Okay. Okay, good morning, everyone. My name is Mohammad Lawal Touru. I'm a research scholar in Tomsk Polytechnic University here in Russia. The title of my presentation today is image segmentation. We're going to look at it comes in two aspects, or it plays a role in both machine learning and deep learning. There is no way we talk about image segmentation without talking about artificial intelligence. And when we're talking about artificial intelligence, we talk about machine learning and deep learning. So now the question is, what is image segmentation? Image segmentation is a subdomain of computer vision and digital image processing, which aims at grouping similar regions or segments of an image under their respective class labels. We can now, since the entire process is digital representation of the analog image in the form of pixels is available, making the task of forming segments equivalent to that of grouping pixels. Image segmentation is an extension of image classification where, in addition to classification, we perform localization. Image segmentation, therefore, is a superset of image classification with the model pinpointing where a corresponding object is present by outlining the object's boundary. So in essence, what I'm trying to say here is image segmentation is very necessary. It has played a vital role, or it's still playing a vital role in both machine learning and deep learning, which is part of artificial intelligence. As we go through the presentation and my topic, and as we go on, you get to understand what I'm talking about. Now, as I said earlier, we cannot talk about artificial intelligence without talking about machine learning and deep learning. They are all parts of artificial intelligence. So, artificial intelligence, as you can see here, is a science devoted to making machine think and act like humans, while machine learning focuses on enabling computers to perform tasks without explicit programming. On the other hand, uh, deep learning is a subset of machine learning based on artificial neural networks. So now, in artificial intelligence, an example is, for example, is maybe carrying a tray of drinks through a crowded bar and serving them to the correct customer is something servers do every day. But it is a complex exercise in decision making and based on a high volume of data being transmitted between neurons in the human brain. Computer In these cases, when we're talking about machine learning and deep learning, this computer match the complexities of human intelligence. Computer excels at applying rules and executing tasks by sometimes a relatively straightforward action for a person might be extremely complex for a computer. Machine learning and deep learning are steps towards a key element of this goal, analyzing large volumes of data and making predictions based on it with little human intervention as possible. So now what is machine learning? As we said, it's a subset of artificial intelligence focusing on specific goals, setting computers up to be able to perform tasks without the need for explicit programming. Once programmed, the computer can take in new data indefinitely, storing and acting on it without the need for further human intervention. Um, Before I continue, I want to remind the audience that you could just, when you're listening to me, you should have like a pen and a piece of paper to jot down some points. I believe there's going to be a quiz after every topic or every subtopic, as the case may be. Okay, as I was saying, over time, the computer may be able to recognize that a fruit type is of food, even if you stop labeling your data. This self reliance is so fundamental to machine learning that the field breaks down into subsets based on how much ongoing human help is involved. An example of this machine learning is computers are fed structured data as data inputs. You can put them in columns and rows. You can create a column in Excel, call food, and have a row such as fruit or meat. This form of structured data is very easy for computers to work with, and the benefits are obvious that one of the most important data programming languages is called structured query language. Basically, this machine learning is categorized into three. We have supervised learning and semi-supervised learning. Supervised learning is a subset from the name. You see, there is human intervention, a subset of machine learning that requires the most ongoing human participation, hence the name supervised. The computer is fed training data and a model explicitly designed to teach it how to respond to these data. Unsupervised learning takes this a step further by using label or labeled data. The computer is given the freedom to find patterns and associations as it sees fit, often generating results that might have been apparent to a human data analyst. And the other part, which is mostly not talked about, is the reinforcement learning, which is the type of reinforced learning is critical to helping machines master complex tasks that come with large, highly flexible, and unpredictable data sets. This opens the door to computers that are trying to achieve a goal, perform surgery, drive a car, scan luggages for dangerous objects, as the case may be. How machine learning works. Um, in the case of supervised learning and unsupervised learning, once an example is once the model is in place, more data can be fed into the computer. to see how well it responds. And the programmer or the data scientist can perform accurate predictions or can issue corrections for any incorrect responses. Picture a programmer, for example, trying to teach a computer image classification. They will input images and task the computer to classify each image, confirming or correcting each computer output. Over time, this level of supervision helps one helps the model into something that is accurately able to handle new data sets that follow the learned patterns. But it is now efficient to keep monitoring the computer's performance and making adjustments. In semi-supervised learning, the computer is fed a mixture of correctly labeled data and unlabeled data and searches for patterns on its own. This labeled data serves as guidance from the programmer, but they do not issue ongoing corrections. The other part I talked about is the unsupervised learning. Okay, an example of this unsupervised learning is a machine learning paradigm for problems where available data consists of unlabeled examples, meaning that each data point contains features without an associated label. As the name suggests, from the name, unsupervised learning is a machine learning technique in which models are not supervised using training data sets. Instead, models itself find the hidden pattern and insight from the given data. It can be compared to learning, uh, which takes place in the human brain with learning new things. A very good example of this is clustering, association, or dimension reduction. The last is the reinforcement learning, which is a machine learning training method based on rewarding desired behaviors or punishing undesired ones. In general, a reinforcement learning agent is able to perceive and interpret its environment, take actions, and learn through trial and error. In supervised learning and unsupervised learning, there is no consequence to the computer if it fails to properly understand or categorize data. But what if an example, like a child at school, it received positive feedback when the child did the right thing, and negative feedback when it did the wrong thing. The computer will presumably begin to figure out how to get specific tasks done without trial and error. Knowing it's on the right track when it receives a reward, for example, a score, then reinforces its good behavior. Hence, we can see that reinforcement learning is a type of machine learning method where an intelligent agent, as the case may be, we say that as a computer program interacts with the environment and learns how to uh, act within that. Uh, how, for example, how a robot dog learns the movement of his arms is an example of reinforcement learning. So we've discussed how machine learning works. And in summary, as I said in this section, machine learning is a form of AI that teaches computers to think in a similar way to humans do, learning and improving upon past experiences. It works by exploring data and identifying patterns and involves minimal human intervention. And lastly, machine learning uses types of techniques, supervised learning, which trains a model on known input and output so that it can predict future outputs, and unsupervised learning, which finds hidden patterns or intrinsic structures in input data. Uh, in conclusion to this part or section, machine learning today, what are the examples of machine learning? Uh, we can you can say like we can give examples of machine learning has become part of our day-to-day activities. Basically, one we say Google uses it to filter spam, malware, and attempt phishing emails out of our inbox. The bank and credit card is used to generate warnings about suspicious transactions on our accounts. When we talk to Siri and Alexa on our phones, which we use on daily basis, machine learning drives the voice and speech recognition patterns at work platform. Sorry, at work. And when your doctor sends you to a specialist, machine learning may be helping them scan X-rays and blood tests result for anomalies like cancer. We've talked about machine learning. Now we're going to talk about deep learning. From the name, deep learning is a class of machine learning algorithm that uses multiple layers to progressively extract higher level features from the raw input. For example, in image processing, lower layers may identify edges, while higher layers may identify the concepts relevant to humans, such as digits or letters or faces. Example of these algorithms include, there are a lot of algorithms that are used in deep learning, but some of for the sake of this presentation, I'll be discussing only convolutional neural networks and recurrent neural networks, which are very common. Other types of algorithms include long short-term memory networks, generative adversarial networks, radial basis function networks, multi-layer perceptrons, self-organizing maps, deep belief networks, restricted Boltzmann machines, and autoencoders. So now, what is deep learning? As the case as we want to do, okay, deep learning uses artificial neural networks, as the case may apply, to perform sophisticated computations on large amount of data. It is a type of machine learning that works based on structure and function of the human brain. Deep learning algorithms train machines by learning. For example, industries such as healthcare, e-commerce, entertainment, and advertising commonly use deep learning. Furthermore, deep learning networks learn by discovering intricate structures in the data they experience, by building computational models that are composed of multiple processing layers. The network can create multiple levels of abstraction to present the data. Deep learning models introduce an extremely sophisticated approach to machine learning and are set to tackle these challenges because they have been specifically modeled after the human brain. Um, in a neural network, or what is a neural network? When we say deep learning network uh, uses artificial neural networks, a neural network is structured like the human brain and consists of artificial neurons, also known as nodes. The nodes are stacked next to each other in three layers, which are known as one, the input layer, the hidden layer, and the output layer. Types of deep learning algorithms that I've discussed, a growing number. There are a growing number of them make these goals reachable and achievable. Uh, for the purpose of this presentation, we're going to discuss only convolutional neural network (CNN) and the recurrent neural network. Convolutional neural networks are specially built algorithms designed to work with images. The convolution in the title is the process that applies a weight-based filter across every element of an image, helping the computer to understand and react to elements within the picture itself. So now, these convolutional neural networks can be helpful when you need to scan a high volume of images for a specific item or feature. For example, images of the ocean floor for signs of shipwreck, or a photo of a crowd for a single person's face. The science of computer image and video analysis and comprehension is called computer vision, and represent a high growth area in the industry over the past decade. Examples of this convolutional neural network include computer vision, face recognition, and image classification. Now, the recurrent neural networks. Meanwhile, introduce a key element into machine learning that is absent in simpler algorithms. Memory, the computer is able to keep past data points and decisions in mind and consider them when reviewing current data, introducing the power of the context. Now, this recurrent in recurrent neural networks. This has made recurrent neural networks a major focus for natural language processing. Like with a human, the computer will do a better job understanding a section of text if it has access to the tone and content that comes before it. Likewise, driving directions can be more accurate if the computer remembers that everyone following a recommended route on Saturday night takes twice as long to get to where they're going or their destination. Examples of these recurrent neural networks, they remember past inputs due to an internal memory which is used for predicting stock prices, generating text, transcription, and machine translation. Um, how deep learning algorithm works. I think we've already given an example on the first part. Deep learning models make use of several algorithms where no one network is considered perfect. Some algorithms are better suited to perform specific tasks. To choose the right ones, it's good to gain a solid understanding of all these primary algorithms. As I said earlier, there are different algorithms that are used. For example, if you could use a different algorithm. For example, the you could use one maybe one can be better for image classification and one is better for uh, face detection. That's the point I'm trying to make. Okay. Differences between this deep learning and machine learning. Well, one is human intervention. In human intervention, machine learning requires more ongoing intervention to get results. Deep learning is more complex to set up but requires minimal intervention thereafter. Secondly, is the hardware. Machine learning programs tend to be less complex than deep learning algorithms and can often run on conventional computers, but deep learning systems require far more powerful hardware and resources. This demand for power has driven uh, the increased use of GPUs, which are known as the graphical processing units, are more useful for their high bandwidth memory and ability to hide latency. That's delays in memory transfer due to thread uh, parallelism, the ability of many uh, operations to run efficiently at the same time. The third difference is time. Machine learning systems can be set up and operate quickly, but may be limited in the power of their results. Deep learning systems take more time to set up but can generate results instantaneously, although the quality is likely to improve over time as more data becomes available. The fourth difference is approach. Machine learning tends to require structured data and uses traditional algorithms like linear regression. Deep learning employs neural networks and it is built to accommodate um, large volumes of unstructured data. Applications. Machine learning is already in use in your mailbox, our banks, the doctor's office. Deep learning technology enables more complex and autonomous programs like self-driving cars or robots that perform advanced surgery. There is no way we talk about image segmentation. Now we've talked about different the machine learning and deep learning. I've given you a clue, an insight of what we're talking about. There is no way we talk about image segmentation without going to the main traditional image segmentation techniques. Well, this is like a block diagram of the traditional image segmentation techniques. We have this image segmentation originally started from digital image processing coupled with optimization algorithms. These primitive algorithms made use of methods like region growing uh, and snakes algorithm, where they set up initial regions, and the algorithms compared pixels values to gain an idea of the segment map. This method took a local view of the features in an image and focused on local differences and gradients in pixels. Um, Algorithms that took a global view of the input image can much later on with methods like adaptive thresholding, uh, Otsu's algorithm, and clustering algorithm being proposed amongst classical image processing methods. So, the threshold method is one of the easiest and one of the most popular image segmentation, where a threshold is set for dividing pixels into two classes. Pixels have values greater than the threshold value are set to 1, while pixels with values less than the threshold values are set to 0. That's for the thresholding method. Then the region-based method segmentation algorithm works by looking for similarities between adjacent pixels and grouping them under a common class. In the edge segmentation method, also known as edge detection, is the task of detecting edges in images. From a segmentation-based viewpoint, we can say that the edge detection corresponds to classifying with pixels in an image, edge pixels, and singly out those edge pixels under a separate class correspondingly. We have the clustering-based method. Modern segmentation procedures depend on image processing techniques, generally make use of clustering algorithms as like segmentation. Clustering algorithms perform better than their counterparts and can provide reasonably good segments in a small amount of time. An example of this clustering algorithms, the K-means clustering algorithm, which is very popular. We have the deep learning-based method, which is these are the main traditional image segmentation techniques, most popular. Then we now talk about types of segmentation. Uh, Basically, there are two types of segmentation. You see from the diagram now on the left, uh, we have the semantic segmentation, which from the diagram you can see it differentiates the cat, the background, the, you see we have the sky, the trees, and the grass and the cat. So with four, so just pixels. So you see the four, the image has been divided into four parts, which in the you have the grass, the cat, the tree, and the sky. You see, no object, just pixels. Then the second diagram here, we have single object, which shows only the cat. Then object detection. Here, you see, we have three different animals. Has been able to detect, show different the dog, which is bigger, smaller dog than the cat. Then the instance segmentation, dog, dog, cat, but in a form of pixels. So now, as I said, deep learning based this types of segmentation. I said you probably have heard about object detection from the pictures and image localization. When there is a single object in an image, we use image localization technique to draw a bounding box around the object. In the case of object detection, it provides labels, as you can see from the diagram, with the bounding boxes. We can predict the location as well as the class to which each object belongs. So you see, we have the dog, dog, and the cat. Then the image segmentation result is more granular information about the shape of an image, and thus an extension of the concept of object detection. We divide the images into regions of different colors which help in distinguishing an object from the other at a final level. So we say we have the instance, semantic segmentation provides segments, map, and output corresponding to the inputs they are fed. While the instance picks different objects and categorizes them into different categories. So this, as I said, we've already discussed this. So what I've said is in semantic segmentations, all objects of the same types are marked using one class label, while in instance segmentation, similar objects get their own separate labels. So we could see that from the diagram. You see this, the semantic has its own label, the instance has own separate labels. Applications of image segmentation. Well, here are a few of the most, I'm going to discuss about a few of the most popular real world use cases of image segmentation. One is robotics. Image segmentation aids machine perception and locomotion by pointing out objects in their path of motion, enabling them to change paths effectively and understand the context of their environment. Uh, after apart from locomotion, segmentation of images help machines segregate the objects they are working with and enables them to interact with real world objects using only vision as a reference. This allows the machine to be useful almost everywhere without much constraint. This includes examples, instant segmentation for robotic grasping, recycling object picking, autonomous navigation, and SLAM. Autonomous navigation. Then we have we have medical imaging. Coincidentally, or this is the part of my research I'm working on. I would maybe in the conclusion, when I'm concluding, I will give you an insight on it. I will talk about what I am working on. But here, medical image segmentation, it involves there are two mostly. You talk of medical imaging and you talk of medical image segmentation. Okay, in medical image segmentation, it involves the extraction of regions of interest, as you could see from the diagrams I showed you as examples. When you're identifying these pixels or this region, there are regions of interest. For example, if you're working on maybe on the chest, X-ray of the chest, and it happens that this patient has infiltrations, maybe this mucus or everything in the chest. With the aid of this medical imaging, you could be able to pinpoint this region and region of interest, and you get an idea of the real picture of what is inside this patient. So extraction of region of interest from 3D image data such as MRI, magnetic resonance imaging, or computed tomography, which is the CT scan. Medical imaging is an important domain of computer vision that focuses on diagnosis of diseases from visual data, both in the form of simple visual data and biomedical scans. Examples of this form of segmentations using image segment diagnosis of this disease can only be speed up, but can also be made cheaper, thereby benefiting thousands across the globe. This includes examples are the X-ray segmentation, the CT scan segmentation, the dental instance segmentation, digital pathology cell segmentation, and the surgical video annotation. On the other hand, as I said, we talked about what do you call it? This medical image segmentation involves the extraction of region of interest from 3D images such as MRI, CT scans, while on the other hand, medical imaging is important domain is a domain of computer vision that focuses on diagnosis of diseases from visual data, but both in the form of simple visual data and biomedical scans. Then we have the smart cities. Smart cities often have CCTV. We know what all CCTV cameras are for real-time monitoring of pedestrians, traffic, and crime. This monitoring can be easily automated with the help of image segmentation. With AI-based monitoring, crimes can be reported faster. Road accidents be followed up with immediate ambulances. Speeding cars can be easily detected, caught, and penalized. Uh, the what certain situations happen maybe at a certain time. For example, maybe if with the aid of this CCTV, maybe at a point in a particular street, for example, maybe if there's a robbery case at a certain time when you say 10 o'clock in the night, the CCTV cameras around these areas are monitored and seen, and with the aid of this image segmentation, uh, the face of this criminal or the incidents can be seen with the aid of this CCTV, which will have been recorded and stored. Okay, examples of this the use of this AI-based monitoring can thus improve the lifestyle of, as I give an example, the pedestrian detection, traffic analytics, license plate detection of cars when they speed, over speeding, or when an accident has occurred, maybe hit and run, then video surveillance. The other, I think, the last. Okay, we have okay. These are the examples that I've discussed. We have self-driving cars. Self-driving cars are one of the biggest application of image segmentation, with the planning of routes and movement depending heavily on it. Semantic and instance segmentation helps these vehicles to identify routes, patterns, and other vehicles, thereby enabling a hassle-free and smooth ride. Uh, we see from our applications, maybe from this Google Maps and yeah, with different applications that uses the GPS, especially when you're trying to find your way through the streets and the road. We come across certain situations maybe during the what do you call it, the rush hour. It could be in the evening after work or maybe during break time. You find a traffic of movement. So with this applications, you can be able to know the best route to follow, the route that has a lot of traffic. This is all part of the image segmentation, the semantic, and the instance segmentation. So some of these the benefits of these self-driving cars, what image segmentation have introduced, include drivable surface semantic segmentation, car and pedestrian instance segmentation, in-vehicle object detection, stuff left that this are an example of like maybe things you go into like a public transport and you forget your bag or stuff like that. So these are like stops left behind by passengers. And another important thing is maybe when you're on the road, these applications, they can be able to direct you and tell you there is pothole detection and segmentation. So from my diagram, as I said, robotics, machine vision, robots, you can see from the diagram, robots working in industrial applications they need visual feed from the diagram you see. This is used to navigate, identify parts, collaborate with humans, and fuse visual information with other sensors to enhance their location information. This is the reason for the use of machine vision in industrial application. Medical imaging. as I discussed, you see, image segmentation can be used to extract clinically relevant information from medical reports. For example, image segmentation can be used to segment tumors in the brain. Then I talked about smart cities. We all know what cities are. We have smart manufacturing, smart government, smart health, smart transportation, smart buildings, smart homes. The smart cities, which we know is from what we have here, it's a technologically modern urban area that uses different types of electronic methods and sensors to collect specific data. Information gained from that data is used to manage assets, resources, and services efficiently. In return, that data is used to improve operations across the city. This includes data collected from citizens, devices, buildings, and assets that is processed and analyzed to monitor and manage traffic and transportation systems, power plants, utilities, water supply networks, waste, criminal investigations, information systems, schools, libraries, hospitals, and other community services. From self-driving cars, as we discussed, segmentation can be used to using self-driving cars for giving easy distinction between various objects, be it traffic, signboards, humans, and cars. It can help the driving instruction algorithm to better access the surrounding before generating the next instruction. Another thing which I did not talk about is I felt is necessary I include it is circuit board detection defect detection. For example, a company has to bear the responsibility of defected devices. If a camera backed with an image segmentation model keeps scanning for defects produced in the final product, a lot of money and time can be saved in fixing a defective device. Um, the companies that try to come up with circuit boards, like maybe in computers or companies that construct computers and maybe phones, manufacture phones and computers, it takes a lot of time and to identify problems on the board and the circuits. So with the aid of this image segmentation, um, you can be able to detect the boards that have problems or if a board has no fault. Then we have the phase detection. We have the phase detection, which I didn't talk about. Nowadays, we have observed that the majority of cameras and phones support portrait mode. Portrait mode is technically an outcome of image segmentation. Apart from this, security surveillance will be much more effective when the faces are distinguishable from noisy objects. So, you see, the first thing is when the camera, the process, I felt I should just put it, maybe to give us an idea of how this works. When the camera focuses on the face, it tries to search the features, we have different features, the eyes, the nose, the mouth. Then it tries to compare the uh, positions and triangulation. Then the feature is extracted. Okay, now the advantages and disadvantages of image segmentation. Well, I believe there are just one. The most important is the main goal of segmentation is to make easy, simplify or change the presentation of an image into something that is meaningful and easier to analyze. This segmentation is typically used to locate objects and boundaries, which includes lines, curves, etc. in images. That is the main advantage. The main drawback is the lack of clear definition of segmentation. There are many uh, types of different algorithms, each with a different definition, while some group edges into closed contours. Other group pixels into super pixels, and at the end of the day, they all make a decent job. Okay, now the image segmentation architecture. The basic architecture in image segmentation consists of two parts, the encoder and the decoder. So from this diagram, if you could remember, we talked about the three layers, which is the input, the output, and the layer that the encoder decoder layer. So the process this the process this the encoder's main job is to extract feature from the image through filters. The decoder is responsible for generating the final output, which is usually a segmentation mask containing uh, the outline of the object. Most of the architectures have this architecture or a variant of it. So examples of this architectures, there are many. So this UNet, UNet++, Fast FCN, DeepLab, etc. We have image segmentation libraries. I know it's going to be this a whole different topic on its own. Maybe some other time we could discuss more on the architectures and the image segmentation libraries. For the case of purpose of this lecture, I decided to just list some of these image segmentation libraries. We have NumPy, TensorFlow, Keras. They are some of the most popular segmentation libraries. Okay, now what is the future of image segmentation? Okay, we from here I decide to summarize. Satellite imaging and military applications are regarded as future trends in the field of image processing. Furthermore, advances in broadband devices and mobile technology will help in the improvement of image processing systems in handheld devices. Others include sophisticated optical sorting. That's when it comes to the eyes, the retina, improvement in augmented reality, traffic data collection, medical imaging, rise in industrial applications, space exploration. You know, we could just send robots instead of going to the moon, you send robots to go and make your survey, try to check around, detect the temperature, which you'll be here on Earth, the distance of millions of miles. You can be able to feel the temperature, the humidity. You can be able to know the texture of the soil. You know, um, military applications. We see what is happening now. We have different types of warfare materials with the technologies, you know. This you send you have different missiles, intercontinental missiles. We have drones from the comfort of your room or your location. You could send to thousands of miles. We have the fingerprint and retina recognition with a lot of institutions or organizations. They use this for security reasons. When you're a worker or if you're a worker or you're trying to gain access into a facility, you have to provide all this, especially if you're going into different countries now with the security situation. Improvements in stereography, and lastly, the morphological image processing. Thank you for listening to me. If you have any questions, you can please ask me.
Thank you, sir, for your nice presentation. Sir, thank you, sir.
Yeah, welcome.
Sir, now we will go our quiz session. After completed our quiz session, we come back in our question answer session.
Okay.
Okay, sir. You have to wait for some
Uh,
minutes.
okay, no problem.
Dear participant, now we will go for our quiz session. To join this session, you have to go slido.com. After that, you have to enter the code. The code is IGP. After short video, we will start our quiz session. Let's enjoy our quiz session. Dear participant, now we'll start our quiz session. To join this session, you have to go slido.com. After that, you have to enter the code. The code is IGP. We will pick your name from Slido, so join with your full name, which will directly print on certificates. Top 10 will be awarded with quiz completion certificates. 25 people join in our quiz session. To join this session, you have to go slido.com. After that, you have to enter the code. The code is IGP. Dear participant, after some minutes later, we will start our quiz competition. To join this session, you have to go slido.com. After that, you have to enter the code. The code is IGP. Now we will start our quiz competition. First question. What does this image describe? First option recurrent neural network. Second option feed forward neural network. The correct answer is first option recurrent neural network. Our second question. Image classification is first option supervised, second option unsupervised. And the correct answer is option 2 unsupervised. Third now question. What is customer segmentation task belong to? First option supervised learning, second option unsupervised learning. And the correct answer is option 2 unsupervised learning. Question number 4. Which operation do not have the desired effect on an image with a heterogeneous, non-homogeneous illumination? First option segmentation with a global threshold. Second option segmentation with an adaptive threshold. And the correct answer is segmentation with a global threshold. Five now question is what is not true about new architecture of neural networks for image classification? First option reinforcement learning can be used to select the design. Second option they are simplified to improve the performance. And the correct answer is option 2 they are simplified to improve the performance. Six now question. To filter noise and keep sharp contours in the image, one can best use first option the averaging filter, second option the median filter. And the correct answer is the median filter. Seven now question is in image classification, what is segmentation? First option separating and labeling parts of an image. Second option detecting parts of an image. And the correct answer is option 1, separating and labeling parts of an image. Question number 9. Allow experimentation with image recognition capabilities based on models trained on dataset. First option WSL embedding, second option dance pose. And the correct answer is option 1, WSL embeddings. Question number 9. Dash allows for the classification of a given image as belonging to one of a set of predefined categories. Uh, First option localization, second option image classification. And the correct answer is image classification. Last question. Which of the following parameters is relevant for city image quality as input data in radio mix? First option, field of view. Second option, all of this. And the correct answer is option 2, all of this. Congratulations, Nico Dancy Mario. Miro. He's a top ranker. Uh, Congratulations, top 10 quiz competition winner. Today, quiz competition winners, we have all of your names which you entered during joining. We will pick and prepare certificate and we'll post them on our Facebook official page. Our Facebook official page is Institution of Global Professional. Dear participant, now we'll go for our question answer session. After short video, we start our question answer session. Let's enjoy question answer session. Dear participant, now we start our question answer session. Hello, sir.
Yeah, I can hear you.
Welcome, sir. Now we start our question answer session.
Okay.
Dear participant, if you have any question, you can ask in our comment box. Sir, our first question. Good afternoon, sir. To summarize, what are the key difference between deep learning and machine learning?
As I said, And in a summary, machine learning and deep learning are both parts of um, artificial intelligence. They are subsets of artificial intelligence. Uh, Machine learning mostly deals with, in a summary, in a layman's language, how you understand. In learning deals with mostly uh, from the name, machines, programs. You see, we talk of the computers, Google inboxes. It deals with codes. Then deep learning mostly deals with images, but the machine learning is a subset. Both are subsets of what do you call it? Of artificial intelligence. Deep learning mostly uses images, for example, maybe from pictures, while machine learning mostly is related to codes that are related to computers and machines. I hope that answers your question.
Thank you, sir. Uh, our second question. Good day, sir. Why is MS segmentation needed and or why is it important?
From what we discussed, we've talked about the what image segmentation, the breakthrough it has brought so far. We've talked about robotics, we've talked about medicals, we've talked about self-driving cars, we've talked about circuit boards. Let me give you an example of. I said I was going to talk about it. I said my research, what is related on, what is based on. I'm working on medical imaging. So let me give you this. Maybe it will help you and you understand what I'm saying. Okay, my medical imaging research program is related to the lungs. So if I want to get an idea of what is wrong in the lungs, maybe let's assume a patient is diagnosed with pneumonia, and we know pneumonia is related with infiltrations, like maybe a portion of the lungs that has a content of maybe pus or a lot of infiltrations gathered in one place. So if I happen to have like a CT scan of this image, I use this segmentation methods or image segmentation methods, which might be maybe in a hospital. I could have like a patient that has similar diagnosis that has that infiltration. So instead of me coming to blindly try to diagnose a patient with the aid of this image segmentation, it will be made easier because you just make a comparison with the patient that has had this recent or has had this ailment before. You make a comparison with this CT scan that you have with what the patient has. You can be able to detect a little portion of, have an idea of what these infiltrations are. I don't know if it makes sense to you or you understand what I'm saying. I've listed the importance of all these things and the applications with robotics, with daily day-to-day activities, the face detection for security reasons. We've talked about the self-driven cars and the traffic semantic and instant segmentations to detect traffics on the road, security, health. So I believe basically these are the main reasons, and I hope that answers your question.
Thank you, sir. Dear participant, if you have any question, you can ask in our comment box. We are still waiting for your question. Sir, our third question. Good
Mhm.
afternoon, sir. What can say about Mr. Elon Musk's inventions?
His interventions, you see, basically these are also related to the robotics I talked about. What he's trying to do is trying to find how what is he doing? He's trying to see how life, if humans can live in another planet. And what does that entail? It entails basically just trying to use robots. You make all your instead of going sending humans to Mars, you send robots to go and time, they detect the humidity, the temperature, the level of oxygen, all these basic necessities that humans require on Earth. You try to make a comparison and see, and you try to know if it is possible and feasible for humans to live on a different planet. It's simple. It's all robotics and it's all part of image segmentation.
Okay, sir, there is no more question. Uh, Thank you, sir, for your wonderful presentation. Uh,
Thank you very much.
Thank you, sir. I hope the participant can learn from your presentation. Any last word for our participant?
The last word I said I was going to talk about, I want to say it again. I said my research is related to image segmentation. So there's something that is referred to as for example, if I'm going to work on maybe patients that have pneumonia, and all I need to do is I try to get data sets. So these data sets are divided into three categories. One, there are free data sets that are accessible online on the internet. There are data sets that you have to subscribe to, and in some cases uh, you have to pay. Then there are some data sets that you hardly get this information from maybe hospitals. Let's assume there is a record of maybe in a hospital that they have diagnosed over time. Okay, let's look at example of this recent COVID-19 outbreak, the pandemic. So now there is basically no hospital you go to or any country you go to that you go to the hospital that don't have this records of people that have had this, that have been diagnosed with this COVID-19. So what you do basically to make things easy, you get these records of these people, that have this COVID from the CT scan. It shows like deposition or the infiltration of pus or whatever from the diagram. These things are called they're referred to as data sets. So if you are trying to use this image segmentation to identify patients that have this diagnosis or diagnosed with COVID-19, what you do is you try to get access to these data sets, and with these data sets you use the programming, either Python programming language you use to train these data sets. When you train them, uh, any what do you call it, any s- patient that has this that is diagnosed or that has this COVID, you can be able to detect with the use of this programming language, either Python or deep learning, which is all under image segmentation. So this is what I'm working on, and as I said, other aspects that this image segmentation has helped in our day-to-day activities include the robotics, the self-driven cars, which helps to detect the CCTV, which helps to aid and reduce the level of crime. And basically, this is what I have for you.
Thank you, sir. Thank you so much to share your valuable knowledge. Thank you so much.
Mhm.
Dear participant, our webinar is topic is on image segmentation, machine learning, or deep learning. Our certificate code is IGP 4844. Our certificate code is 4844. IGP 4844. Thank you everyone for your active participation. I hope everyone can learn from our webinar. Stay happy and blessed. Thank you so much, everyone.